Okay. In today's lesson, our focus for today's session is going to be on one of the topics, but I'm going to ask you, we have a driving question. Have you ever tried to divide something complicated into simpler parts? You can raise up your hand and you share with us what is that thing that you have ever tried to divide into simpler tasks or into simpler parts, and then you share with us. In case there's anything you have ever divided, feel free to raise your hand, or you can just simply type in the chat and then I'll be able to get you. Yes, Jimmy.
Yes, like dividing the oranges after maybe removing now the outer parts, then dividing one by one to a friend.
Okay, thank you. That is one. Any other person? In case there is anything you have divided, kindly I want you to share with us. So, yes, yes, Jackie. Okay, Vincent, unmute. Vincent, unmute and share.
Yes, maybe even dividing what? Tomatoes into different parts.
Adrian, share. Adrian, you can share, and Jack.
Yes, for me, I thought dividing, but like for example, you can divide some like a sector of a what sector of something like a shape, and then you get some other shapes.
Okay, thank you for sharing. Nadia, share. Nadia, okay, okay. So thank you so much, everyone, for sharing. That is true. There are quite a lot of things we keep on dividing, like some of you have mentioned them here. So the topic we are going to deal with, take an example. Some of you always celebrate your birthdays, and you find yourself that you have to share that piece of cake. You divide it into smaller parts. When you are still in primary, you were studying about the syllables, how you divide things. So the topic we are going to deal with it's going to be involving dividing things into small parts. The way you see this cake here, this cake has been divided into small fractions. So when you look at this cake, it was a whole, but then it went on to be divided into small parts. So this topic, take an example. When you go to school, your parents always give you pocket money, but you plan for this pocket money. You divide it into smaller fractions. So you notice that at first, someone may have, they may give you pocket money, say 20,000 shillings. Then you have to divide this money into smaller fractions. So you divide some, you say, I'm going to spend some money on the canteen. I can spend some money on the textbooks, but also I can spend some money on savings. So you find that initially you had 20,000, but you have divided it into small parts. So you have got your 20,000, divided some say 10,000 for maybe canteen. You have gone on to say 5,000 will be for saving, and then 5,000 for textbooks. So you divide something into smaller fractions. So that means that when you look at the diagram I'm using, I've divided the whole into different fractions, say a third, and then a third. What does it mean? It means that the topic we are going to deal with, it's going to be involving dividing or decomposing bigger fractions into smaller fractions. That is what we are going to be dealing with. Take an example. I have an activity here. When you look at the fraction, in the chat, can you type in what do you think our A is equal to? And what do you think our B is equal to? This is where our A is, and this is where our B is. What digits do you think are missing in those parts? Type in the chat quickly. Jack is saying B is 4, B is 1, A, A is 1, A is 1, B is 4. Very good, very good, very good. Yes, you are correct, members. So you notice that here our fraction, we have 3 out of 4, and members are saying A is 1, and people are saying that our B is 4, which is really very, very correct. Now, this is very okay, and this is very okay. So that is very, very correct. Now, what have we done? At first, we had our fraction, which was 3 out of 4, but we have decomposed. That is now the word I want to use, decomposing. In simple terms, we call it splitting. That is the meaning, that we have split our 3 out of 4 into 2 fractions, into a quarter, into 2 quarters. What does it mean? It means that now we have got parts. That is the meaning, that the 3 quarters, we have now obtained 2 parts. We have obtained a quarter and we have obtained the 2 quarters. Now, what does it mean? It means that now this topic that we are going to deal with is going to be dealing with what you call, from parts, we shall develop what you call partial fractions. Now, the a quarter and the 2 quarters is what we call the partial fractions. Then this initial one is what we call the rational fraction. I want you now, we are starting the topic. The first one, we call it the rational fraction. Then the 2 that we divide, we call them partial fractions. Members, can you let me through the chat whether we're on the same page? What we call a rational and what we call now the partial. Just say yes, we're on the same topic. We're on the same page. Okay, members are saying yes, yes. Now I'm going to repeat once. I'm saying that a rational fraction, any fraction that you can write in form of A out of B. Rational comes from the word ratio. Ratio means two parts, like A to B. So any fraction you can write in terms of A out of B, we call it a rational fraction or a rational number sometimes. Now, when you divide that rational thing into two or more fractions, then they become parts, or what you call the partial fraction. Now, we are going to be the topic we are going to be dealing with, we are going to look at fractions. But now we are going to extend this knowledge into algebra. We are going to be finding things. Let me say 3x plus 4 out of x plus 1 into x plus 3. Now, we are going to extend the knowledge we have from how we split one fraction into different fractions into our algebra, whereby now we are going to be splitting algebraic fractions. But before we reach there, can I give you an example? And members can tell me, I'm going to give you 2 out of 5. Members in the chat, can you give me 2 or more? I want you to split 2 out of 5 into partial fractions. What could be our answers? Yes, place them in the chat. I want now, we are splitting 2 out of 5 into 2 other fractions. Very good. Jack has said 1 out of 5. One has given us 1 out of 5 plus 1 out of 5. Very good. 1 out of 5, 1 out of 5. There's a 1 out of 5. Yes, that is okay. Now, the 1 out of 5 and the 1 out of 5 is what you call the partial fractions. Someone, Wizard, has said 3 out of 5 minus 1 out of 5. That is also very correct. Now, these are partial fractions. These are parts. Okay. I think, 2.5, 0.5. 3 out of 5 minus 1 out of 5. 4 out of 5, very good. Thank you, members. Now, those are what you call now the partial fractions. So the topic, yes, this is pure mathematics. So in case you are here and you are not doing pure mathematics, kindly you can. However, feel free to stay around. In case you are doing sub-math, you may meet it somewhere, but it's not necessary. For sub-math, you can drop off the call. Okay, so members, that is how we are going to be dealing with. So the way we have separated this fraction 2 out of 5 into 1 out of 5 plus 1 out of 5, or 4 out of 5 minus 2 out of 5, or 3 out of 5 minus 1 out of 5 is the same way we are going to be dealing with splitting of algebraic fractions. So we are going to start dealing with things like 3x out of x plus 1, x plus 3. And now we are going to be splitting this into 2 or more parts. And now that is the topic we are going to be dealing with. So here in this session, we are going to focus on how can we split now where we have unknowns. How can we split where we have unknowns? So that is the topic we are going to deal with. The way you have these chocolates, at first you can have a fraction. I've showed you. So you keep on separating, you keep on breaking it. So we are going to look at how we can break those fractions, one fraction into other smaller fraction. And therefore, our topic today is going to be partial fractions. If you feel we are on the same page, you have got an idea on what partial fraction is, any you are correct, then kindly write the topic, partial fractions. Anyone, can someone raise up the hand and you just tell us what you think partial fractions are? What you have understood so far from the start? Yes. Yes, Jack.
For me, I think partial fractions, these are fractions that can be, or these are split fractions to make a rational fraction. So these are fractions that can be added to make a rational, or they can be subtracted to make a rational fraction. Yeah.
Okay. That is very good. Thank you. Prisca?
Me, I think in partial fractions, we are splitting a fraction such that if you add all you subtract the splitted fractions, you get the original fraction.
Very good. Thank you. That is correct. Nadia? Jime or Ruth or Helen?
Partial
I,
fraction is another way to represent a rational fraction.
Okay. Very good.
Partial,
Continue,
partial
Helen.
fractions. I think partial fractions are those ones derived from rational fractions.
Okay. Okay. Thank you so much, everyone. And now we are going to go to the competency. Now, at the end of this topic, by the time we finish, one, you must be able to decompose. And I've told that decomposing means splitting a ratio expression into different parts. Now, the knowledge we are going to acquire here, we are going to use it in calculus. We are going to use it when we are dealing with integration. One of the topics you are going to cover is going to be integration. Some of the topics you are covering now, you are going to be applying that knowledge when it comes to integration, when it comes to differentiation and other topics you are going to be meeting. So anything you cover as a foundation, always take it seriously because it's going to be helping you in the topics that are going to be following. So this is our competence. Then what is our learning outcome? By the end of this lesson, I do expect that each one of us on the call will be able to decompose a proper fraction. That's going to be the first one I want us to concentrate on. You must be able to decompose a proper fraction. And later on, we shall look at how do we decompose an improper fraction. If you get that, then we shall have achieved the learning outcome for this lesson. Now, I gave you an assignment in the group. We are going to have people, you raise up your hand and you give us at least the meaning of each of the words from what you have searched about. Okay, I'm going to start with Sheila. Sheila.
Okay, decompose is to break down a number into smaller parts.
Okay, thank you. That is correct. Sheila, yes, please.
Proper fraction. Proper fraction is a fraction whereby the numerator is smaller than the denominator.
Okay. Thank you, peace. Jimmy.
improper fraction, this is a fraction like where the numerator is greater than or equal to the denominator.
Okay. Thank you. Judith.
A quotient is a number gotten after dividing two numbers.
Okay. Thank you. Nadia.
Judy said my answer.
Okay. What was your answer? Okay. Priska.
Me, I was also going to talk about a quotient. Is the result of dividing one number by another, having the dividend, which is the number being divided, the divisor, the number by which we are dividing, and then resulting into the quotient, the result of the division.
Okay. 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 That is very, very good. Help.
Partial fraction is a method used in algebra to break a complex rational expression into simpler fractions that are easier to integrate.
Okay. Okay. Very good. Lastly, Aaron.
Yes, we're going to talk about algebraic fractions. These are fractions that contain variables such as x in the numerator or denominator.
Okay. Okay. Thank you so much. Please, let's take note of those keywords. They are going to be very important in the course of our discussion today. So we are going to be referring to some of these words. Decompose, when they talk about decompose, you know that is splitting. When they talk about proper fractions, you need to know about it. Improper, you need to know about it. Quotient, yes. So we shall keep on interacting with those words. Okay, now I can start on what we call partial fractions. Now, partial fractions are those fractions we obtain after decomposing a rational expression. When we talk about the word rational comes from the word ratio, And I know many of us have heard about a ratio. A ratio is like a fraction. Now, when I talk about a rational expression, it's just a matter of me having maybe P out of Q or 3 out of 4. This is what we call a rational expression. A rational, now here it will be a fraction. So that is what we call, it means splitting something into 2 or more different fractions. It can either be addition, it can be subtraction. I've given an example of what we call a rational expression. Like I've said that here we are mainly going to be dealing with algebra, where we are going to be dealing with X, we are going to be dealing with Y and the rest. But we are going to be decomposing or splitting them into 2 different fractions. So this is our first fraction and this is our second fraction. So we are going to be splitting. We get a bigger fraction, we split it into 2. Even they can be 3, they can be 4. So we are going to be splitting them into different fractions. But at the end of the day, when you get these fractions you have split, they must be able to give you what you had initially. Okay. Hope class we are on the same page. You can take note something from this page. Okay. Yeah. So you can take note something. You can maybe make some little note. Okay. Others, you can even take a screenshot. It can work well. You can take a screenshot such that we can. But writing always has a way it helps things to stick. You draw a neural path in your brain and things are able to stick very, very well. When you finish, you let me know through the chat and then we shall continue. According to the chat, members are saying we are good to continue. Okay. Now, when you look at my screen, I have an insect here that is carrying a big stone. I want you to let me know. Do you think it is proper or improper? Put your answer in the chat. What does this insect represent? A proper, improper? Sese is saying an improper. People are saying it is really improper. Very good. Now, that is where we are starting from. Now, whenever we talk about something improper, something not fair, it means that what is on the top is bigger than what is down. That is the meaning. So in terms of algebra, I repeat, you notice that what you have at the top, this is like your numerator at the top, is bigger than what you have at the bottom. So bottom is what you call the denominator. In other words, the denominator is going to be small. Hope we are going there. Now, what do I want you to take note? That in algebra, we are going to be looking at the degree. So for anything that is going to be improper, the moment you look at the numerator and is bigger than the denominator in terms of what you call a degree. Now, let me write an algebraic expression here. This is 3x plus 4. Now, in an algebraic expression, always we are going to be looking for something to be bigger. You look at the highest power in that expression. Now, when you look at this algebraic expression I've written, 3x plus 4, we are going to be looking at the degree. In simple terms, the degree is the power on the variable. So here we are going to look at the power on x. When you look at the power on x is a 1. So meaning that this expression has a degree 1. You look at the highest. This 4 has an x, but its power is 0. So you read off the highest degree. When I write 3x squared plus 4x, here the degree of this expression is going to be 2 because that is the highest power. Hope members we are getting it. Let me write here and you place for me the answer in the chat. Class, what is the degree for this expression I've written? What is going to be the degree? Very good. The degree is going to be 3. Very good. What about when I write this? What is going to be the degree for that expression? Put it in the chat and we see. What is, make sure you look very well. Always we consider the highest degree. You always look at it and say, what is the highest degree on x? That is what you look at in order for you to say, this expression has a degree of 5. Very good. Very good, members. That is okay. Now, whenever we are dealing with a fraction, we are going to be studying the degree, whether it is bigger or whether it is smaller. I will give you an example. I have this. Now, I'm giving a fraction. Now, class, when you look at this, I want you to look at the numerator and look at the denominator. What is the degree for the numerator and what is the degree for the denominator? Now we are starting. What is, people, numerator, the degree is 2. Yes, denominator is 1. Numerator 2, denominator is 1. Very good, class. When you look at this particular one, you are noticing that our degree, the highest degree here is the 2. So for the numerator, its degree is 2. When I go to the denominator, its degree is 1. And therefore, whenever the power, whenever the degree of the numerator is bigger than that of the denominator, then we shall say that that fraction is an improper fraction. Whenever it is greater than. Now, I want to add on the second phrase that whenever it is greater than or equal to, then that one is an improper fraction. Have you got it? I'm adding the second phase, that whenever the first one was greater than, now whenever it is greater than or equal to, then that one is going to be an improper fraction. So I'm giving another example. You will tell me, I have x plus 2, x squared plus 2 plus 2x plus 1 out of 3x squared plus 3x plus 1. What is the degree of the numerator and the denominator, class? You can place it in the chat. What is the degree of the numerator and the denominator? Paul has said 2 Alex, 2 Marriage, 2 Vincent, 2. Very good. Yes. Now, yes. The moment you note that they are the same, are equal, then that fraction is also improper. Class, hope that is very fine. Can now someone raise up the hand and you tell us, what do you think a proper fraction? We have talked about an improper. What about a proper fraction? What do you think it is? How can you define it now in your own words? Lollipop.
I think a proper fraction is a fraction where the degree of the numerator is less than the degree of the denominator.
Wow, thank you, thank you, thank you so much. That is very correct. Flona, do you have anything to add on? Or Priska?
Me, I think when you talk about the improper fractions, here the numbers whose index of the numerator is equal or greater than that of the denominator.
Wow, that is very correct. Now, class, can we write those definitions somewhere in your book? Okay, yes, Jonathan.
I think the numerator must be a linear equation. So as to be a proper fraction. The numerator must be a linear equation. So as to be a proper fraction.
Oh, okay, okay. Now, Jonathan, with the time, you are going to find out that even you can find when it's not a linear one. It can even be a quadratic. Yes. For you, the thing you need to look at always, look at the degree. It's what now determines whether it is proper, whether it is an improper fraction. And even going forward, dear members, the way we are going to be dealing with a fraction that is proper and improper will be different. Those are different people, so we shall be dealing with them a bit different. Okay. Precious, do you have anything? Okay. I think we are good to go. Class, are we good to go? For proper, numerator is less than denominator. That is very good, Elijah. Okay. People are saying we are good to go. Yeah. So, okay. 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 We have talked about this. I don't need to go to it again. We have talked about the proper and then the improper. Okay. Okay. I have my exercise here. I have my exercise here. I don't know that we need to use the chat. People need to raise their hands. But we are doing it in our books. First do it in our books. Then we take 2 minutes and then we mark ourselves. So we are trying. We are going to mark ourselves at the end. Yeah. Okay. Okay, in case you have finished, you can raise up the hand and then we share the answer. Okay, there I'm seeing some answers in the chat, but you will give us the reason. You tell us, A, the answer is this because of this and this. Okay, we can start, members. Okay, Precious.
So, teacher, I think A is proper because the denominator degree, cause the denominator's degree is 1 and that of the numerator is 0.
Wow.
And then B.
Hey. Okay, thank you, Precious. That is correct. Help.
To me, I think B is improper because the degree of the numerator and denominator are equal, so meaning it is improper.
Thank you. That is correct. Yes. Priska. Priska. Okay. Nadia.
C is improper because numerator and denominator have the same degree.
Wow, thank you. That is correct. Francis.
So D is improper because the numerator
Continue. Continue.
Oh, sorry. So D is improper because the fraction, the numerator has its, what is it called?
Okay. Zion. Paul. Queen.
E is proper because the degree on the numerator is 1, whereas the degree on the denominator is 2. Because when we expand this, expand these brackets here, okay, when we work out these brackets, which are x plus 2 into x minus 1, we get x squared plus x minus 2. And now, when we compare the degrees, we notice that the denominator has a degree of 2, whereas the numerator has 1, making it proper.
Wow. Okay. Thank you. Must speak.
Yeah. F is I think F the highest degree of the denominator of the numerator, I mean, is higher than the degree of the denominator.
Okay. Okay, then Sheila.
Teacher, D is a proper because the degree on the numerator is less than the degree on the denominator.
Okay, that is correct. Thank you. Then the last one, Rona. Oh, oh, Rona, I'm failing. Lona, Zion. Okay, yes, Rona.
Teacher, I think H is an improper fraction because the degree of the numerator is higher than that of the denominator.
Okay, that is very correct. Okay, thank you so much, members. Your answers are really very correct. And going forward, always do not mind about, let me say, these negatives. For you mind about the powers on X. That one will be giving you an idea. When you find that the brackets are not open, please, you have to go on and open, like this case we had here, x plus 2x minus 1. You notice that when you open, down the highest power is going to be x squared, so the power will be 2, the one up will be 1. Even for this first one, you notice that x was there, but since any number to power 0 is 1, so you notice that the degree here is 1, up here is 0. So the denominator has a higher degree compared to the numerator. And this knowledge is going to be key when we are working out the numbers, because I've told you, always the first thing you're going to check, is it proper? Is it improper? Then now you know that if it is improper, you must always first convert it into proper. In partial fractions, we only deal with proper fractions. Please take note of that. We don't deal with an improper. Once you find that the fraction is improper, you convert it into a proper fraction. That is very okay, members. Take an example. Let me give you an improper. And you tell me, I've given you this. This is an improper. How can we decompose these members? Is that an improper proper? How can we decompose that, members? I want to see whether we can decompose that one. It is an improper. How can we decompose it? I want you to write it in two fractions. If we can. Yes, Precious. Precious? Judith?
I think if it's improper, we need to first divide the numerator to using long division and use its factor to get something smaller.
Very good, very good. So members, whenever you meet such fractions, you have to remember your long division. So we shall be dealing with the long division at a later time. So this is how you decompose it, but we shall look at how we are going to be doing it when it comes to algebra. Thank you so much. That was very correct, Judy. Okay, now we are going to start. Do you need to write this definition? Let me give you a minute in case you want to write my definition, but I know you have yours. Okay, so you can take notes. This is mine, but always put it in your own words, for you the way you understand it. Those things I've explained. Okay, hope members we have finished. Okay. People ask. Yes. Now you can come up with the one for proper. You can come up with the one for proper. Oh, someone is asking, what is a polynomial? Now, when we talk about a polynomial, mathematically it means an expression of more than two algebraic terms. I can give you an example. Let me give you an example. When I write 3x plus 3x, this is what we call a polynomial. A polynomial means that it has more than two terms. A term, like when you have an expression, this is a term and this is a term. But the difference when it comes to polynomials, the degrees are different. Like the degrees or the powers of the variables are different. That is the meaning. So when I write 6x squared plus, let me say 7x plus maybe 3x cubed, this is a polynomial. It has different terms. Each of these individual is called a term. So you have one term, two terms, three terms, but also the powers are different. So this is what we call a polynomial. It can be in different variables or they can be the same variables. Members, are we together on the word polynomial? Those who have been asking, is the word okay now? Okay, perfect. Yeah. I repeat, we have said that a polynomial means an expression whereby the powers of the variables, those are the things that change. Let me say X, Y, Z, what, those ones, they are different. An example I've given you, in case I have 7x squared plus maybe 4. Here, you know, maybe for x plus 1. This one is a polynomial, but this one is a special polynomial we call a quadratic. Now, let me break it now. We have what we call quadratic, whereby the highest degree is 2. So when you keep on advancing, you'll find whereby you have x7x cubed plus 4x plus 1. Now, this one has gone to a cube. Yes, but you'll find expressions where you have 7x power 5 plus 7x power 3 plus 4 maybe x power 2. These are different terms and the powers are different. So when you look at the powers on the variables, if those powers keep on changing are different, then we call it a polynomial. Hope that is okay. Are we good to continue, members? You let me know through the chat whether we can continue. And I want you to write your own definition for a proper. I want you to write your own definition for a proper. We have said that for an improper, do not forget the upper one is the numerator. The downer one is the denominator. And do not forget for improper is greater than or equal to. So I expect you to write your definition for proper by saying it is less than. Okay. Yes. Okay, Maxwell, I think I've explained it. I've, 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 okay. Yes. So in terms of algebra, I have explained it. But here, in terms of partial fractions, I'm going to look at this. Out of x plus 1, something like this. Let me just stop at x plus 1. Okay. X plus 1. So you notice that up, this is a polynomial. Up. Even down, I have a polynomial. Yes. Now, what are you noticing? you are noticing that this algebraic expression here is a polynomial, but we have said its degree is 2. The one down, its degree is 1. So it means that the numerator has a degree greater than the denominator. So it is an improper fraction. So this is what we call a polynomial. That algebraic expression or that expression that is in terms of x or whether in terms of y, yes, it's what we call, yeah, but the degrees of it has different terms. So that the word terms should come out very well. That the terms are like those individual breakdowns that add up to make one expression. Okay. No, it's not used on improper, also on proper. For you, anything to be called a polynomial, as long as it's just this one is also a polynomial. The only difference is that then we can keep on using, when it has a degree 1, it has a special name. We call them linear. When it has a degree 2 as its highest power, we can call them quadratic. When it has a degree 3, we can call them cubic. But beyond the degree 3, then we can just call them polynomials. We may not be specific. Okay. Okay. Class, are we good to continue now? Are we now on the same page? Let me know, and then we continue. Are we on the same page? I want us to start. So if you want to break it, the word polynomial, you can come and do like this. Poly and multinomial. You can break it like this, whereby, you know, in what? You can poly and multinomial. More than 2 parts, that is the meaning. Those who have done Latin, those who are in the seminary schools, more than 2 parts. That is the Latin thing. Okay. Okay, okay. Okay, I think we are good to continue. Okay. Okay, now the introduction. Now, we are going to meet basically 3 types of partial fractions. And that one, we shall classify them depending on the nature of the denominator. I've already told you that when it comes to partial fractions, we mainly deal with the denominator. We mainly deal with proper fractions, nothing different. Now, we have the first case. The first case we have, this is the case number 1. Hope you are noticing my first case. Proper fraction where the denominator has distinct linear factors. What do we call distinct? Distinct means different linear factors. They are not the same. And when I talk about a linear factor, is that factor whereby the power is 1. Take an example. When I write x plus 1, this is a linear factor because that has a power 1. When I write x plus 2, this is a linear factor. It has a power of 1. Those are what we call linear factors. Number 2, distinct. It means that they are different. This is x plus 1, this is x plus 2. Those are different factors. So I can give you an example for those proper fractions where the denominator has distinct. An example, we can have ig, we can have something of this nature. 7 out of x plus 3 plus 3 out of x minus 2. So you notice that we have separated our partial fractions and the factors are different, are linear. That's what we call the first case. Then we have the second case with repeated linear factors in the denominator. What does repeated mean? Repeated means that, take an example, you may have x plus 2 squared. Now, this one means that x plus 2, remember this is the same as having x plus 2, x plus 2. So the linear factor appearing twice or more than that, it means it is repeated. Now, that is the second case. We call proper fraction with the repeated linear factors in the denominator. An example can be, let me say, 7x plus 3 plus 3 out of x minus 2, but when it is squared. Then the third case is a proper fraction with a quadratic factor. Quadratic factor, it means that the power on the factor you are dealing with is 2. An example, let me say I have this as my factor. This is a quadratic factor. So what does it mean? It means that in the denominator, it cannot be factorized. An example I can give you, it can be, let me say 7 out of x plus 3, then plus 3 out of x squared plus 2. You notice that one of the factors in the denominator is a quadratic. So class, can you let me know whether you have picked something from those 3 scenarios I'm giving you? Okay. So we are going to be dealing with those cases at different intervals. But I'm showing you how the scenarios are going to be appearing. Repeated. The second case, repeated. I want you to pay attention here. Repeated, it is here, whereby when you look at the power, x minus 2, it means x minus 2 squared. It means that this factor can be written twice, x minus 2, x minus 2. That is the repeated I'm talking about. So I didn't want to write it like 7 out of x plus 3 plus 3 out of x minus 2, x minus 2. So you note that x minus 2, it is appearing twice. So it means it is repeated. Okay. Then case 3. Yes. Now, yes, Shadow. Now, when we talk about a quadratic factor doesn't mean a quadratic expression. A quadratic factor can as well just be x squared plus 4. This is a quadratic. However, we have said that it should be that one that cannot be factorized. An example I'll give you is that when I have x squared minus 4, now this one doesn't qualify to be called a quadratic factor because you can be able to factorize it as x minus 2, x plus 2. That is the difference. So for anything to be called a quadratic one, it should not be able to be factorized. That is the thing I want you to pick. Okay, yes, Favor.
Okay, my question is, in case where we have a proper fraction with repeated linear factors in the denominator, does it qualify? If I have a fraction with, say, if I get my decomposed fraction as 7 out of x plus 3 and 3 out of x plus 3, when they have the same denominator, is that still under case 2?
First come with that example, 7 out of x plus 3,
Plus 3 out of x plus 3.
Yeah. Now, this one, something like this, Yes, still this is now a repeated one. This is a repeated one. Because when you simplify it, this is 9 out of x plus 3 squared. Have you noticed?
Oh, okay then. Yes.
Yeah, so, okay, yeah. So repeated, it means that it is coming again. It's coming again. But we are going to look at different examples and how to deal with them. Because their expansion will be different from how we expand it. Okay, yeah. Okay, so can we first make some small notes on this page and then we continue? Make some small write-up. Hope Shadow, you have obtained it. So Shadow, when it can, that one you have given me as an example, you thought that a quadratic equation, a quadratic factor should always be like this. Now this is a complete expression, but you'll find that some of these expressions you have, they can be factored. They can be factored, but there are those specific ones where you cannot even continue. Now those ones, you deal with them differently. Hope we are okay. Now take an example. This one you have given. In case I just added 2 here, it means it is the same as x plus 1, everything squared. So this one now qualifies to be called a repeated linear factor. That is now the difference. But there are those quadratic ones you cannot factor. I've given an example like this one. But if you have something like x squared minus 6, you notice that this one you cannot factor it. So this one qualifies to be here. When you find x squared minus 25, then this one is repeated because you can, through difference of squares, you can write it as x minus 5, x plus 5. So hope you are picking the difference. Yes, Shadow, that is okay. X squared plus 2 cannot be factored any further. Okay. Okay. When you finish, you let me know. And then I will continue. Okay. Okay. So people are saying we can now continue. Okay. Yeah. Those who have not yet, you can take a screenshot, but I will also be sharing this. Okay. Now we are going to deal with the first case. The first case we are going to deal with are proper fractions where the denominator has distinct linear factors. That is the first case we are dealing with. Now, dear members, when we are dealing with a fraction, whereby when you look at the factors, I'll give you an example. Take an example, I have 3x plus 2, and I look at the denominator, I have x plus 1, x plus 3. When you look at the two factors I have down, surely they are different. Now, in order for you to obtain the fraction, the partial fractions, the way we separate them is going to just be a out of x plus 1, then plus b out of x plus 3. That's how we separate them. Even if they are 3, even if they are 4, even if they are 5. Even if I have 5x plus 3 out of x plus 1, x plus 2, x plus 3, if I'm separating them, I will always do A out of the first factor plus B out of the second factor, then plus C out of the third factor. So that's how we are going to be dealing with them, with the first case, where the denominator has distinct linear factors. For you, first check out. The first step to do is check out, is it a proper fraction? That yes. How is the nature of the factors in the denominator? That the factors are linear. Therefore, you'll continue. Members, I don't know whether we are there. Are we on the same page, members? Okay. Some are saying yeah, yes, okay. Kind of pattern answer. Okay, I repeat. Like we have said that in partial fractions, we are going to be separating the original fraction we have, or what we have called the rational fraction. We are going to separate it. Take an example. In case I have 5x plus 7, out of x plus 1, x minus 2, this one, you notice, one, check, is it a proper fraction? Then you check, the degree in the numerator is 1. The degree in the denominator is 2. And we have said that since the downer denominator degree is bigger than the 1, it qualifies to be a proper fraction. Now that is 1. Number 2, we look at the nature of the roots we have, or what we call the factors. That these factors are distinct, are different. X plus 1 and x minus 2 are different. Now, the moment you find that they are different, then we are going to separate them. We are going to break them. And now when I'm breaking them, I'll use, say, A, divide by the first factor, which is x plus 1, plus B, divide by the second factor, which is x minus 2. And your task now going forward is going to be to check out what is my A and what is my B, which when I add this fraction, I go back to the first fraction. That is going to be your task. Hope now we are on the same page. What is A, B, and C? A, B, and C are the unknowns that you are going to be searching for, which when you put them there, they give you the original fraction when you compose it again. No, the numerator, we don't deal with the numerator at all. We only deal with the numerator, with the denominator. Teacher, we are looking at proper fraction, but they seem to be improper due to their when you look at the index, dear members, you are noticing that the index here, the one in the denominator is 1. The one down is 2. And we have said the moment the denominator has a higher degree compared to the numerator, then it is a proper. Okay. So what if and not, what if? Now that one, those are different cases. We are going to first understand the first case, then we go to the second case, then we go to the third case. So we need to deal with all the cases different. Let me hope, Mercy, you have obtained a point. Okay. So we are going to do an example. I want you to first take note and then we start on examples. Okay. Okay, I think we are good to continue. Okay, someone is saying, Joseph, Joseph, I don't know that Joseph, you are able to see. Joseph, I don't know that I can get Joseph. Joseph, I'm saying you have Joseph Stephen. Is it Joseph? One of you who is saying the degree is 1. Joseph, you can unmute. When you look at the degree, I want you to look. Joseph.
Yes, sir.
Yes, you are saying the degree is 1.
Yes.
What is the degree for here on X?
Oh, it's 0.
On X, look at X. PX. I think there is a 1 here. So this degree is 1. Then when you look at the denominator here, for you to come up with a conclusion, you have to first multiply them. So the moment you multiply AX times CX, X times X will give you SCX squared. So the degree is 2. So down the degree is 2.
Okay.
So are you noticing? The upper one is 1, the down one is 2. So it is a proper fraction.
All right.
Okay. All right. Okay. 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 I think we are good to continue, members. We are good to continue. Yes, Techno?
Okay, teacher, I have this question like, express 1 over x squared minus 2x minus 3 into partial fractions. So like, how do you work on this one?
1 out of x. Oh, Techno, come again.
1 out of x squared minus 2x minus 3 into partial fractions.
Oh, okay. Now we are going to deal with this one as well. We are going to deal with it. After the example, we are going to see how to do it. Okay. Mr. Ronald? Mr. Ronald, would you love to say something? Okay.
Mr. Kaziba.
Yes, Mr. Ronald.
Hello?
Yes, Mr. Ronald, you are clear? Yeah.
Sorry, you wanted me to say something?
Yeah, you can say something and then we continue.
No. No, I just want to welcome all those who are online, the students who are studying mathematics in senior 5. We appreciate the effort you are putting in. We would like to encourage you to do your best. But also remember, whatever you are learning during holidays, please, when you go back to school, try to teach the others because they may not have gotten an opportunity to learn. When I was at school, I used to learn most during holidays, and I would go back and participate in discussions to support the others. And that is how, as a class, we grow the capacity to perform well. We don't only rely on the teachers we find in school. So when you can, please discuss for the others and ensure that you pass on the knowledge you have gained. And also remember, whenever you discuss for someone, you learn better. So I'd like to encourage you to read harder, learn more, and then go back to school and support the others. I also thank you, Mr. Kaziba, and your team for organizing these lessons for us. Thank you.
Okay, thank you so much, Mr. Ronald. Okay, so class, now we can start with the first activity. Yes, we are going to start with our first activity, and our first activity is going to be express 7x minus 1 out of 1 minus x, 1 plus 2x into partial fractions. So we have said always the first step is to check, is your fraction proper or improper? Who's telling us? Is it proper or improper? That is the first thing you have to check out. Is it a proper and improper? Yes, Pavin.
Teacher, for me, I think that the expression is proper because
Why?
because when you look at the denominator, we have 1 minus x into 1 plus 2x. So when you multiply x and 2x, you get negative 2x squared. So that becomes a 2. So yet up we have a 1. That means it is proper because the degree on the numerator is smaller than that of the denominator.
Wow, wow. Thank you so much, Pavin. That is very correct. Now, the moment you identify that it is proper, then the next thing we go on, we ask, what is the nature of the factors in the denominator? Are they distinct? Are they different? If the answer is yes, then we are good to continue. I want to just ask whether Jack has a question. Jack, do you have a question?
No, I didn't have a question. Just I wanted to say that the denominators are distinct.
Very good. The denominators are distinct. Now, the moment we identify that, now we are going to go to the first step. Now, the first step, I'm going to have my side work here. So we are going to separate. So I'll say 7x minus 1 out of 1 minus x into 1 plus 2x. Now, I want you to take note. I'm using equivalent. Are you seeing those ones? Not equals. I'm using equivalent. Then I will say a out of the first factor, which is 1 minus x, plus b out of the second factor, which is 1 plus 2x. Now we have started to decompose, to split. Class, are we on the same page there? I don't want to leave anyone at this step. Are we on the same page? We are splitting, okay? Very good, very good, very good. That is very okay. Martin, any question? Or Baker at that step?
Yeah. Teacher, why do we use the equivalent symbol and not the equal sign?
Because, now, for you to use an equal, it is when you are very sure that those two expressions are equal. But when you look at 7x minus 1, it's not equal because here we have two unknowns, a and b. We can only use equals after us verifying that it is true. Hope you have got the point. That since we have not yet obtained what a and b is, they are not yet equal. So it is after you have made your calculations and you have found that a and b is this and this, that's when we can use an equal sign. Okay. But it will depend on the book you are using. In some books, you'll find them using equals, but the proper one should be the equivalent. Now, when we come at this point here, dear members, we are going to work out the fractions. But I'm going to first teach you the first approach. Then the first approach allow me to use side work. Yeah, because now I want us to simplify it. When I have 1 out of 2 members plus 1 out of 3, mathematically, do you know what I can do? I can come, I have this one multiplied here. So I can have 1 times 3. Here I have a plus. Plus, I have these 2 multiplied here. So I'll say 1 times 2. Then everything I multiply what I have in the denominators as 2 times 3. If you have picked that, kindly let me know in the chat whether that one is very okay. No, A and B are unknowns. A and B are unknowns, eh? Yes. Okay. Okay. It is very okay. Very okay. Very okay. Very okay. So, alternatively, those who don't want to use this approach, you are going to come and say, in my denominator, I have 2 and 3. So what is my LCM? My LCM is going to be 6. So you start 6 divided by 2, you get 1. Then you say 1 times 3 plus 6 divided by 3 is 2. So you say 1 times 2 divided by your LCM, which is 6. That is the second alternative. But I want us now, if you can only master this one, it will be very good for us. What do? I'm going to put another example. When I have A out of B plus C out of D, mathematically, you can just say, I'll have these 2 multiplied. So I multiply A times D. Then here I have a plus. I cross multiply here. I say B times C. Everything, I multiply what I had down, which is B times D. And that is the approach I want us to use here. Now, hope that is okay. Now, class, you are going to allow me to come and say, this is equivalent to, I'm going to cross multiply. So I'll have A into 1 plus 2x plus B into 1 minus x, everything 1 minus x into 1 plus 2x. And we have said this one is equivalent to 7x minus 1 out of 1 minus x into 1 plus 2x. Class, is that step fine for everyone? Let me know through the chat. Very good. Very good. Very good. Now, the moment, class, you get that, let me first pick Serena and Pavin. They have a burning question.
Teacher, for me, I was asking, do we always use a positive? We don't consider the sign in the numerator.
Perfect. Perfect. The answer is a yes, Pavin. The way you have thought about it. Is that okay?
Yes.
Okay. Yes, Selena?
It was my question as well.
Oh, okay. Yes. For you, always consider plus. The other things will sort themselves at a later time. Now, when we reach here, members, you are going to notice that what you have this side is the same with what you have down here. Now, I want to show you that mathematically, when I have this, let me say this is x. The moment these two are the same, I can cancel them in simple terms. So the moment you reach this step here, where I am, just equate the numerators only, since the denominators are the same. So I don't want you to go into the math. This math of you are going to say, now I'm going to multiply this side by 1 minus x1 plus 2x. I multiply this side also by 1 minus x, 1 plus 2x. Then this and this cancel, this and this cancels. No, there's no need for you to go up to that level. So the moment you notice that the denominators are the same, just equate the numerators. So I'm going to come here and I say 7x minus 1 will be equivalent to A into 1 plus 2x plus B into 1 minus x. Now, the moment you reach here, I'm going to teach you 2 methods. then it will be up to you to choose which approach is going to be very easy for you. Method number one. Method one. Now, method one involves choosing appropriate values of x. That is the first approach. I'm going to write it here. So I have 7x minus 1 equivalent to a into 1 plus 2x plus b into 1 minus x. Now, choosing the right values of x, in other words, what we are looking for, we are looking for a and b. We are looking for the value of a and b. You can ask yourself, if I want to remove this b, what do I need to do? If I want to remove b, what do I do? Now, always, I want you to look at the factors you have. You look at these factors. Those factors are going to help you when you are eliminating the value, whether you are eliminating A or you are eliminating B. I'll give you the first case. Now, the first case, I want you always, what you do, you want B to disappear, meaning that everything here can become a 0. Now, what are you going to do from that step? I want always you do your side work that my factor is 1 minus x. If I want B to go and I obtain my answer for A, the whole of this one must equal to 0. So you will say 1 minus x is equal to 0. So this will be 1 minus x plus x is equal to 0 plus x. And therefore, 1 is equal to x. Now you are going to come and say now, for x is equal to 1. So you are choosing the right values of x such that you can eliminate one unknown. So when x is equal to 1, members, I'm going to substitute. Where there is x, I put 1. So I'll have 7 times 1 minus 1 is equal to my a, 1 plus 2 times 1 plus b into 1 minus 1. Wherever there is x, you put 1. So 7 times 1 is 7 minus 1 is equal to a into 1 plus 2 plus b. 1 minus 1 is 0, so it will be b times 0. So I'll have 7 minus 1, which is 6, equaling to a into 1 plus 2, which is a 3 plus 0. So mean that my 6 will equal to 3a. So my a will be 3a divided by 3, which is equal to 6 divided by 3. So my a is equal to 2. Class, can you just say yes if we are on the same page, how we have eliminated? Okay, that is very good. If we are on the same page, that is very okay. Now I'm going to ask you. Now I'm going to, okay, pardon. Some people asking for pardon. Yes, not really very okay. Pardon. Okay. Now I'm going to pardon for some people. Now, when you reach this point here, your task should be, how am I going to obtain the value of A and the value of B? So to obtain one of those values, for you, what you do, look at the factor you have. Equate this factor to 0. The moment you equate to 0, you are going to be eliminating one of them. I'll go to the second part. The second factor is 1 plus 2x. So I'm going to say 1 plus 2x is equal to 0. So your intention is to find what is your x. So what are you going to do? You're going to say, when I take the 1 minus 1 plus 2x will equal to 0 minus 1. So we shall have 2x is equal to 0 minus 1, which is negative 1. So you divide by 2, divide by 2. So your x will equal to negative a half. That means that the value, choosing an appropriate value, you are going to choose a value x is equal to negative a half. Then this value you choose is the value you are going to substitute in this expression here. I don't know whether now we're on the same page, members. I want to know, are we on the same page there? Okay. Yes. Same page. Now, may I ask members to substitute for me x is equal to -1/2, and we see what do we get for the value of b as I pick the hand here. Yes, Helen.
Teacher, I do not understand why you wrote a over 1 minus x plus b over 1 plus 2x, yet we have 7x minus 1. Don't we consider that C?
Okay, Divine, before you go, Divine, did you
Yes,
pick the
teacher.
idea of what we call a partial fraction?
Yes.
Explain, what does it mean?
A partial fraction is one that's gotten after dividing. Okay, after making the, how should I explain? The complicated fraction. Yeah, the complicated rational fraction smaller.
Very good. Now we are trying to split it, not so?
Yes.
Now, when we are splitting, we are not sure which two fractions we are going to obtain when we split. So A and B are representing the A out of 1 minus x and B out of 1 plus 2x represent the results we are going to obtain after simplifying this complicated one. Are you getting the idea? Oh. Helen, you can come back a bit. Helen, are you picking the idea?
Yes, teacher.
Yes. So, as separating them into two, we are trying to find out what are those two fractions, which when you add back, you get back the complicated one. So that's why we always say A out of that, but you also always consider the kind of denominators you have. So we are dealing with the first case of distinct. Are you getting it?
Yes, I am.
Okay. Are we good to continue?
Yes.
Okay. Baker?
Sir,
yes.
I wanted to inquire. Immediately you find the value of x. You remove the equivalent signs.
If you wish, it is very okay.
And the next thing is, can I use the value of a and the value of x to find the value of b?
Can you use the value of a?
Yeah,
and
since I found a,
Hmm.
and say a is our 2, and x was 1. Can I replace in this equation to find the value of b?
You'll get a 0. You'll not be able to get the value of b. If you want to do it that way, then you make x to be another value apart from 1. That particular value you have used to get a.
Okay, sir.
Okay. Yes, Jack?
So I was saying about the answer of B.
Okay.
Yes, I had got it, and it's -3.
-3. Okay. Can you take us through how you have obtained -3? Class, allow me to write up here.
So when you look at, we are making our value of 1 plus 2x is equals to 0, as we have done it here. So we obtain our value of x will be a -1/2, don't so?
Yes.
Yes, then for the value of a would be 0. So a would be equal to, so this will be, no, sorry, it will be 7x minus 1.
So we substitute.
Okay, 7 into -1/2.
Okay.
Minus 1, sorry, is equivalent to a into 0.
Okay.
Plus b into 1 negative a half.
Okay.
Yes. So when you come this side, it will be negative 7 over 2 minus 1 is equivalent to 0 plus b into 3 over 2.
Yeah.
Are we on the same page?
Yes, I hope so.
So this would be, so when you add negative 7 over 2 minus 1, so when you make it 1, it will be negative 9 over 2 is equivalent to b into, yes, that's it. So the denominators go. So you remain with negative 9 is equivalent to 3b. Yes, then you divide both sides by 3 and your b would be a negative 3.
Wow, wow. Thank you. That is correct, members. Thank you, Jack. So those are the answers you get. Now, after obtaining those two answers, members, you are going to come back and place those answers where there is A, where there is B. Where there is A, where there is B. So where there is A, we shall place 2. Where there is B, you'll place your negative 3. So I'll expect that we shall come back and, can I write on the same page? I'm saying my page here. I'm congesting it, but allow me to write here just A. But I'll come back and I write, I say 7x minus 1, 1 minus x into 1 plus 2x is equivalent to A, which is going to be 2 out of 1 minus x, then plus B, which is negative 3 out of 1 plus 2x. Now, as mathematicians, so there is, you may plus and a minus gives you a minus. So you can, instead of just writing plus minus, you can decide to ignore this and just place here that minus 3 out of 1 plus 2x. Class, I don't know whether we're on the same page or we are leaving someone. Are we on the same page? Are we? Yes, if you use another value, not, if you use Big Dad, please, those who are not, some people are not on the same. Okay. Okay. I have put Trevor in the waiting room. Okay. Now people are saying, pardon, I want to know which exact point you want me to repeat. Okay, when you use any other value of x not 0, do you get the same answer for A as negative 3? The answer is yes. When you obtain one value of your unknown, let me say you have obtained for A or B, one of them, you can use any other value of x, not the one you used to substitute to get the other constant. It is very okay. Here, let me say, for this particular number, allow me to, I'm going to erase my screen. That is the meaning. Take an example. For this particular number, we have obtained our value for A as 2. Now, if I want to get the value of B, any other value of x apart from the one I used to get A, can help me to get B. Take an example, x is equal to 0. So for that one, I'll come and I say 7 times 0 minus 1 will be equivalent to A. My A is 2 now, into 1 plus 2 times 0 plus B into 1 minus 0. So 7 times 0 is 0, so I have negative 1 equaling to 2. 2 times 0 is 0, so here I will have 2. Then here I have plus B. 1 minus 0 is 1. So here I'll get negative 1 minus 2 equaling to B, which is negative 3 is equal to B. So it is okay. For whatever other value used for x, as long as you have obtained one constant, it can help you to get the other constant that might be remaining. Presh.
Excuse me, teacher. If someone opens the brackets, like for example, we had the value of x as 1, right? And someone you open the brackets and say like, before you open the brackets of x, you say like a times 1 plus a times 2x, making you to get a plus a to x. Is it right, or you are prolonging the methods?
Yeah, you are prolonging the approach, but it is also very correct, Presh.
Okay.
Vincent?
Sir, really, okay, we have got the value of A as 2. So can we use values which are less than 2 or any?
For values of x,
No, like we got A. Yeah, to get B.
Yeah, you can
we
use
use
any
the values
you can use values that are less than or bigger than. Even if you use 100, you'll get the answer.
Okay, sir.
Okay. Daniel? Okay. Members, allow me now to go to the second approach. That is approach number 1. Now, approach number 2, or method number 2, allow me to go to another screen. Now, method number 2. Now, method number 2, still you solving the same number, involves equating coefficients. Equating coefficients. Now, what do we have? We come back, we are up to this point. This is where we are. Equivalent to A into 1 plus 2x plus B into 1 minus x. That's where we are. Now, what does this mean? Now, this approach, the second approach, it means that when you reach this point, you are going to open the brackets. So I'll come and I open. This A, I'll multiply it here. The A will also affect here. So I'll have A times 1 plus A times the 2x plus I'll have B times 1 minus B times x. What will I have? I'll have A plus 2ax plus B minus bx. And still this one is still equal to 7x minus 1. Members, are we still on the same page? Are we still on the same page? Gilbert is saying, yeah, Julie, yes. I'm opening now the brackets. I'm opening the brackets. I'm opening the brackets. What we are doing, when you are opening the brackets, remember, this B affects what is inside. The way you are doing it, let me say into 1 plus maybe x, or maybe x. Like the way you have 2 into 1 plus x. What you do, this 2 affects this. This 2 will affect this. So you say 2 times 1 plus 2 times x. So that is what we are doing. The only difference that here, instead of 2, we have A. Now, when we reach here, we collect like terms. Those with x, put them alone. Those without x, put them on different. So I will start with the one without x. So I'll have A plus B. So I'm collecting like terms. I'm collecting this A and this B. Then from there, I'm going to bring those with x. 2ax minus bx still is equivalent to 7x minus 1. Now, the moment I reach here, I continue to make them better. So this is a plus b plus, now x and x is common. So since x is common, I'll have 2a minus b, everything into x. And this one is equal to 7x minus 1. Hope class we are still on the same page. We shouldn't leave anyone behind. Jody says yes. Elisha says yes. Gilbert, okay, we're on the same page. Now, the moment we reach this point, we are going to equate those. Now, this side, when you look at this side, you have a value which has x as the coefficient. You have the one without, so you equate. Those with x, equate them. Those without x, equate them differently as well. So we are going to equate the coefficients of x and the constant. Is that okay? That's what we are going to do. So I'm going to say a plus b, I'm going to equate it to -1. Then 2a minus b, I'm going to equate to 7. Are those two equations clear now? Are we seeing them very well? People are seeing them. I've seen someone of Samsung not picking it well. Samsung, kindly unmute and you let me know where. Okay, anyone who has not yet picked from this point, kindly raise up your hand such that we can help you. Yes, Sheila. Sheila, unmute. Oh, Sheila is not unmuting. Bill Levy. Yes.
Like if you are equating those, we don't even include x values, as in when you equated a plus a 2a minus b equals to 7.
Now, Sheila, are you seeing? There is an x and an x this side. Are you seeing?
Yes.
So they cancel like this. So that's why we don't include them.
Okay, sir. Thank you.
Okay. Bill Levy.
Sir, that was the same question I was asking.
Oh, okay. Daniel.
Yeah, I was also like that's
put here.
Oh, you were asking the same. Okay. So members, that's how the x go. Now, you'll note that now what we remain with, this is a spontaneous equation. So now you solve it the way you want. If you remember how to solve spontaneous equations, you solve them. So you use any method of your choice, either the elimination, substitution, matrix, any method of your choice. But according to me, I can just add the two equations since b and b have different coefficients. So when I add, I can simplify quickly. So a plus 2a, I'm going to obtain 3a. b plus negative b is a 0. -1 plus 7 will give me a 6. So I divide by 3, and my a will equal to 2. Similarly, when you solve that equation, you'll get the value of b as -3. So I don't know whether that one is very, but use any method of your choice. You always use the method of your choice. The one that is much easier for you. Yes, Maxwell and Levy.
Excuse me, sir. I had some terrible network. I got left behind. Where you're still saying 7x minus 1 is equals to a plus b plus into brackets 2a minus b x. I'm lost how you have a plus b is equals to -1, then 2a minus b is equals to 7.
Okay, now Maxwell, what we did, we equate when you reach this level. The one where for constant, I equate constant. So a plus b is a constant, I equate to a constant what I have this side. Then this one with coefficient x is 2a minus b. I equate it with what has x this side.
Okay,
So
thank you,
that's
sir.
how we came up with the two equations.
Okay.
Okay. Yes, Trevor.
Good afternoon, sir.
Good afternoon.
Yes, some people are saying that, okay, you said that method one, okay, like you go with any method, but yesterday, as you told us to do some research, I found out that some parts where like only method two can apply, where method one cannot work.
Now, it depends on how the
Yes, so I
number
was
is
saying
set.
that maybe like
Continue. Okay. Now, all these approaches we are having, all of them can work depending on the number you are doing with. But knowing both of them will help you a lot. You can master both. There is no problem. You can first learn the first one very well and learn the second one. It will depend. More so if you go on with numbers, whereby you are going to find that the coefficients have a lot of unknowns. There are some numbers you may find. I can give you an example whereby they have a lot of unknowns, like the x powers are increasing, whereby the moment you equate to 0 or to something, you almost notice something is vanishing. So you need to learn how to factorize for other numbers, but learn both methods. It will be very good for you. Okay, I think we are good to continue. Now, after finding this, I've said you go back and make your conclusion in the first equation. So you say your A is 2 out of x minus, so it is 2 out of 1 minus x and minus 3 out of 1 plus 2x. Yeah, so you conclude like that. Okay. Okay, so that's where you end. But both methods are doable. Yeah, but I want you to master. Because the moment you master, you'll notice that here things are very easy for me. Here they are not. So you go with what is easier depending on the number. But let's learn both. Yes, okay. Okay. Members, you let me know through the chat whether now we are good to do some numbers on our own, or we need to do one more number. Let me know through the chat whether to do one more number or we feel we are okay. One more, good to go, one more. Okay, one more. Okay, we can do one more. Okay, one more. Okay, allow me to put that number. Which number? And please here, do not feel bad. There are times when you are going to get fractions. Don't get disappointed. Now look at these fractions. No. There are times when you are going to deal with fractions. There are times when you are going to deal with negatives. So you need to just get used to working with them. So I have another one here. So still we are dealing with just distinct. So we have said that the moment you notice one, it is a proper fraction. Yes. Are the factors distinct? That yes. Then we shall go on and say this is equivalent to A out of x minus 1 plus B out of x plus 4. That should always be your first step. Now, after that step, we have said that now we are going to deal with what we have on the right-hand side. Now, what we have on the right-hand side, I've showed you that always, for you just come here, be like cross multiply that and that. So when I cross multiply that, you notice that I'm going to have A into x plus 4. Plus, I'll come to the second one, I cross multiply this. So the moment I cross multiply that, I'll have B into x minus 1. Then we said after that, for you what you do, come to the denominators, multiply the 2. Multiply those 2. So I'll have x minus 1 into x plus 4. And that one would be equivalent to 2x minus 1 out of x minus 1, x plus 4. Class, are we on the same page? Is that step fine to everyone? Okay, that step is very, very okay. Okay, okay, good. Now we continue. Now what we are going to continue, we say the moment you look at the denominators when they are the same, then for you what you do, equate. So I'm going now to say 2x minus 1 is equivalent to a into x plus 4 plus b into x minus 1. Then the moment you reach here, for you, what are you going to do? You are going to ask yourself, which approach is easier for me to use? Then you say, method 1 can be easier for you. Then you say, in case you are using the first method, you say method 1. Now, the beauty with method 1, you are not going to deal with a lot of simplifying things. So you'll find yourself things are working out. More so if you are dealing with distinct roots, things will be very easy for you to deal with. So what are you going to do? But there are some numbers you are going to deal with whereby you'll have to mix the two methods. So I'll come here and say, this is a into x plus 4. I want, through the chat members, can you let me know? I want to remove b. What should our appropriate value for x be? I want to remove b. What should our appropriate value be? X is equal to 1. Very good. X is equal to 1. Those who are not here, we say that to remove b, I'll come, I want to make this one 0. So I will say x minus 1 is equal to 0. So x minus 1 plus 1 is equal to 0 plus 1. My x is equal to 1. So we shall say now x is equal to 1. So we substitute throughout everything. So we shall have 2 times 1 minus 1 equaling to a into 1 plus 4 plus b into 1 minus 1. Now, since 1 minus 1 is 0, the whole of this one will die. So I'll have 2 minus 1 equaling to a, 1 plus 4, which will give us times a 5. So 2 minus 1 is a 1 equaling to 5a. And therefore, by 5, by 5. So my a is equal to 1 out of 5. Now, after getting my 1, I can go back and substitute. Now, members, what could be our other appropriate value for x in case we want to eliminate a? In case we want to eliminate a, we want to eliminate what? People are saying -4. -4, good. So you can say now x is equal to -4. So you substitute. So it can be 2 times -4 minus 1 equaling to our a into -4 plus 4, then plus our b into -4 minus 1. So you notice 2 times -4 is -8 minus 1. -4 plus 4 is 0, so this one will die. So I'll remain with b into -5. -1 minus 1 is -9, equaling to -5 times b. So since you are interested in b, I'm going to divide. So I'll have my b equaling to 9 out of 5. The negative and the negative cancel. So that's why you remain with just b equaling to 9 out of 5. Now, after getting your a and b, you go back and you substitute in the original equation here what your a was and what your b was. So you notice that our a was 1 out of 5. So I write 1 out of 5, everything out of x minus 1, plus 9 out of 5, everything out of x plus 4. But as a mathematician, you are going to convert your answer into a better way. Yes, so you can go back. In case I have a out of b out of 2. Members, this is the same as a out of b divided by 2, which is the same as a out of b times 1 out of 2, which is the same as a times 1, which is a out of 2b. So in simple terms, whenever I have 1 out of 2 out of maybe out of 3, this is the same thing as writing 1 out of the denominator and the denominator, 2 times 3. So here we can write it in a better way as 1 out of 5 into x minus 1 plus 9 out of 5 into x plus 4. Okay, hope that is okay. Can I take on some hands? Yes, Patience.
Excuse me, teacher. I'm very sorry to take us back, but I lost connection when we had just found the value of A. And
Okay.
I'm a
Where?
bit lost from there.
Where we got x is equal to negative 4? Patience?
I got lost from where you said A is equal to 1 out of 5.
1 out of 5. Okay.
Yes, sir.
But is this step fine from here to here? This step here. No. Patience. Don't unmute. Don't mute. Don't mute. Patience.
Yes, please.
Yes. Did you get how we substituted in the value for x is equal to 1?
Yes, sir. I understood.
Then what about this step here?
No.
Okay.
No, yes, I did. Yes, I did.
So then 2 minus 1, Patience, we had a 1 equaling to
Yes, sir.
5a. Was that fine?
Yes, sir. Yes, sir.
Then after we went on and said to get a, we divide both sides by 5 by 5.
Yes.
So that's how we got 1 out of 5 is equaling to a. Is that okay?
Yes, it is.
Now we went on to have a eliminated, and we say that always get that factor equate to 0. So you say x plus 4 is equal to 0. So this gives us x plus 4 minus 4 equaling to 0 minus 4. And therefore, x will equal to 0 minus 4 is negative 4. Then this negative 4 you have obtained is what you get and then substitute in that original expression you had. Is that fine?
Yes, it is.
So when you substitute, wherever there is x is where you substitute. So we are going to substitute here, we are going to substitute here, we are going to substitute here. So you notice that here, 2x minus 4, it will be 2 times negative 4, which gives us negative 8. When I come here, x plus 4, this becomes negative 4 plus 4. Negative 4 plus 4 is 0. So the whole of this one dies away. Then when I come here, I have x minus 4. So it becomes negative 4 minus 1. Negative 4 minus 1 is negative 5. But I have a b, so it becomes negative 5b. Is that okay? But here, Patience, we had 2 times negative 4 minus 1 minus 1. There is this minus 1. So negative 1 minus 1 gives us negative 9 is equal to negative 5b. Then after you divide, divide. So negative and negative cancels. So you remain with 9 out of 5. I don't know that is a bit clear now.
Yes, it is, sir. Thank you very much.
Okay. Jack?
So I was asking about, like, we have a 5 into x minus 1. So can you further simplify it by solving the bracket?
Oh, it is okay. By saying 1 out of 5x minus 5 plus 9 out of 5x plus what? That is 20.
20. Yes, can you say that?
It is okay. Another
Okay, thank
person
you.
even can factor out and say 1 out of 5 into 1 out of x minus 1 plus 9 out of x plus 4. It is very fine.
Thank you, sir.
Okay. Help? Oh. Daniel? Yes.
I wanted to understand, since our first example.
Oh, come again.
I am trying to clarify on this.
Why are you muting? I think there's a problem. Daniel?
Yes, mine is like, where did we get the for x to be -4?
Oh, -4, we have said, Daniel. Are you looking at this?
Yeah, I'm looking.
Yes, we said that we are going to just get this factor with a, which is x plus 4, equate to 0. The moment
Yes.
equate to 0, that's how we are getting x is equal to -4. Have you got it?
I've got it.
Okay.
So, thank you, sir.
Okay. Infinix? Infinix? Okay. Help? Okay. I think I'm not getting those people. Yes, Infinix? Okay. Athieno? Oh. Infinix, you are not so clear. Okay. Sheila?
Sir, what I was saying is that can you send us some questions?
Yeah. It's what I want to do now. I want to do it. Yes. Allow me to go to that screen. Yes. Members, we can take a screenshot of those questions. I want to just make some clarification on two things. One, a case in point. Kindly take note. When you look at part B here, part B is also part B. Still you separate, you say A out of 2x plus B out of x minus 4. Then when it comes to part E, please members, I expect you to say A out of x. X alone is a factor on its own, just because it has plus 0. Plus you say B out of x minus 1 plus C out of 2x plus 1. But I want you please to take note that when they are 3, when they are 3, please now here, the best approach I want you to be very careful. When they are 3, let me give you a good example such that we do not mess up when they are 3. So when they are 3, let me say this is x minus 3. Now, when you are dealing with the 3s, your approach of just cross multiplying may not work very well, may not work for you. What do you need to do? You need to look at what you have in the denominator. That for this particular one, where you have x plus 1, your LCM here is just a matter of you multiplying all. Multiplying x plus 1, multiplying x plus 2, and multiplying x minus 3. And therefore, what does it mean? It means that when you are dealing with A, you'll get the whole of this one divided by x plus 1. So you remain with, I expect A to have x plus 2, x minus 3. When I'm dealing with B, I don't write x plus 2. Instead, I write the other two remaining. So I say plus x plus 1, x minus 3. When I'm dealing with C, I don't write x minus 3. I write the other two remaining. That's when it comes to when you are dealing with a 3. So I expect to apply the same approach for part E and then part F. Hope that is clear. Okay. I think this is okay. I pick one hand, Martin or Einstein, Geoff, any of you to just unmute one of you.
Teacher, I don't know if number part F is okay, but like the numerator has two parts and then like the denominator has 3 parts. So could you please give us a hint on what to do on such a number?
Yes. Now, yes, don't go. Martin, what I'm saying, like for part F, you'll say A out of 2x plus 3. plus b out of x plus 2 plus c out of x minus 3. Now, when you look at what you have in the what? In the denominator. Here, remember, for cross multiplying, we use it for 2. So if you want, you can first deal with this one alone. Then you say this is going to be x plus 2 plus b into 2x plus 3 out of 2x plus 3 into x plus 2. Then plus c out of x minus 3. Then you can deal with this one. Since now this is 1, this is 2. So x minus 3, when you cross multiply, you end up with x into x plus 2, x minus 3, plus b into 2x plus 3, x minus 3, then plus the c into 2x plus 3 minus. So you are going to separate it like that. I don't know whether, is it Martina, you have got a hint?
Teacher, yes, I understood that part, but like the part that is maybe I'm a bit confused is that should we find C? Because like the numerator has 11x. I mean, I'm assuming that 11x is our A, then 12 is our B.
Oh,
And should we find,
yeah. Now, what is going to happen? This is what you are going to have. This is what you are going to have. x2x minus 3 plus b into 2x plus 3, x minus 3, then plus c into 2x plus 3, x plus 2. And this one, you're going to equate it to, it is going to be equivalent to 11x plus 12. Now, you're going to start eliminating one by one. You say, when x is equal to negative 2. Now, x is equal to negative 2. This one is going to be eliminated. This one is going to be eliminated. So you'll be able to get the value of b. Then when you go to x is equal to 3, you are going to find that you are going to eliminate this one. You are going to eliminate this one. You will get the value of c. When it comes to value of the other value, you'll find yourself that when x is equal to negative 3 out of 2, this one goes and this one goes. So you get the value of a. So I don't know whether, Martina, that hint is enough.
Yes, it is. I've understood what to do. Thank you.
Okay. So that is how you're going to deal with those numbers. Is it Edinstein and Maxwell or Geoff?
Yes, excuse me, sir. Previously, when we were working out the other numbers, we like to remain with a 0, we had to equate the x minus 1 or x plus whatsoever is equals to 0. So now how are we going to do that when we have like here where you have like a into x plus 2 into x minus 3? Do we like expand and open the brackets and work out and then we equate to 0, or we just equate one by one?
You equate one by one. Say x plus 2 is equal to 0. So x is equal to negative 2. Then you'll find that this one are dying. So you'll find one variable. When you say x is equal to the other one, so equate one factor by one factor. One by one, one by one. Is that fine?
Yes, that's fine. Thank you.
Okay. Nadia?
So for me, I'm asking, when they are giving us these partial fractions, can they give us more than one unknown when we can find a situation when we have x and y in the same fraction?
Nadia, not really. They will be in one variable at this level. Okay.
Okay.
Okay. Now, in case you are to use the other approach, the other method 2 of equating, you need to be very solving spontaneous equations of 3 should be something that is easy for you. If you are to use the approach of equating the powers. Now, take an example for this. You'll notice that this is x squared. So you notice there is no variable for x squared. So it means that in case you are equating, here x squared has a 0 coefficient. So you say 0, then this side you equate to the coefficient of 0. That is the meaning. So you equate to something like a plus this is going to be 2b, then plus 2c. So x squared has a coefficient 0. So that is what you have to do, those who are going to be equating. Okay, I think, okay. Okay. So I think we are going to end here for today. So that's when you bring in the echelons approach and other approaches, substitution, elimination, and the rest of that. More so when you have 3. But here you can also use your calculator to solve. Otherwise, I think let's end here. Those who came in late, I will share with you the recording. You'll find the recording on the YouTube channel. We shall post it there. Then I noticed, let me first end this recording.